Have you ever traveled from Amsterdam to Paris? Compared to the current modes of transportation, the high speeds of a Hyperloop can ensure a tremendous decrease in travel time. Imagine the possibilities of a complete Hyperloop network. Where would you like to travel to with a Hyperloop? In this lecture, I will explain the most important factors to take into account for constructing a Hyperloop network. First, we will have a look at how we can estimate the future demands. Afterwards, I will tell the main parameters that influence the location of stations. Then it is time to determine the costs to see if the network is feasible. The first question that comes to mind when thinking of a Hyperloop network is, why do we actually need a Hyperloop? Aren't the other transportation modes sufficient? As the costs for constructing a Hyperloop network are high, it is important that the routes will have a high demand in order to be profitable. To design a profitable network, it is essential to estimate the travel demand in the future. However, this is not an easy task, as the future is uncertain. There are multiple ways to estimate the future demand. One method is to use a gravity model, of which this is the formula. The demand between two cities I and J is determined by the population of both cities and the travel time. Instead of population, gross domestic product can be used, or a combination of both the population and GDP. This method is a good one to use for non-existing routes. If currently there is no high-speed transportation network, the factors population and GDP are good predictors for the demand. Another method, which is used by Delft Hyperloop, is to look at the current trips made by aircraft. It is expected that the Hyperloop will take over a significant share of short-haul flights, up to a distance of 1,000 kilometers. That is also admitted by airlines and airports, as they don't want to fly on these short distances, because the longer distances are more profitable for them. Therefore, it can be expected that the Hyperloop might take over many of those current trips. And as the Hyperloop will only be operational in many years from now, an additional growth factor can be assumed, as people tend to travel more and more each year. So, by using air traffic data, we can make a model that is able to give an indication of the future demand on existing routes. After estimating the travel demand between cities, it is time to determine the location of the stations. As the Hyperloop will be the most efficient at high speeds, it would make no sense to transport passengers on short distances. If we take the upper comfortable guideline for train acceleration, which is 0.15 g, a Hyperloop path will take more than 200 seconds and almost 22 kilometers to reach a speed of 1,080 kilometers per hour. The same goes for decelerating at the end of the journey. That means that the Hyperloop starts to be most effective on distances over 44 kilometers. However, you can imagine that the longer the distance, the higher the efficiency. Another aspect to take into account for creating a network are the costs for the infrastructure. The larger the network, the more infrastructure is needed, and the higher the investment costs are. Therefore, it is important to only add a route to the network if the demand is sufficiently large to be able to pay back the network eventually. The European Hyperloop network, created by Delft Hyperloop, is shown here. By connecting 48 cities, the network is estimated to be used by more than 300 million passengers per year. This equals 2/3 of all passengers traveling between these cities. Imagine the reduction of carbon dioxide pollution and thus climate change. The same method could of course be used to create a Hyperloop network elsewhere in the world, such as Asia or North America. And again, where would you like to travel to with a Hyperloop? After this lecture, I hope you understand the main points to be able to determine an efficient network. Thank you for listening, and have fun finding out more about the Hyperloop network in the additional material.